Hello everyone, I am S. Vijay from PG Manufacturing Training first year. I am here to present my mini project on the investigation on the performance of IoT enabled electrochemical discharge machining under the guidance of Dr. T. Sekhar sir, Associate Professor, Department of Manufacturing Training. So let us start from the basic introduction of the ECDM. Electrochemical discharge machining is a novel hybrid machining process used for machining conducting and non-conducting engineering materials, combining the features of EDM and ECM process. So this ECDM process is a combination of two other unconventional machining process, that is electro discharge machining and electrochemical machining. This is basically a hybrid process, and this process is also known as ECSM, that is electrochemical spark machining process. So these are the basic objectives of the project: to measure the voltage range, to measure the ampere rating, to measure the duty cycle pulse on or off time. So these three measurements are directly displayed on the laptop using the sufficient programming language compatible compatible programming language for these three measurements. And the next one, to measure the temperature of the electrolyte. So temperature of the electrolyte is basically measured by the temperature sensor. We use temperature sensor to measure the temperature of the electrolyte. Next one is to measure the pH of the electrolyte. Here the pH indicator is used to measure the pH electrolyte, and to measure the electrode moment by using encoder. So encoder incrementer is used to measure the tool movement in this process, to measure the distance between auxiliary electron and workpiece. For this particular measurements, an ultrasonic sensor is used for its efficiency, and to measure the electrolyte TDS. TDS in the sense total diffusion solids. So total diffuse solids are measured by the TDS sensor. So this is the ECDM setup. Here in the container, there are two electrodes used in this process. One is the tool electrode, and another one is the auxiliary electrode. Auxiliary electrode is directly dipped on the electrolyte, which is will be near to the workpiece. And here on the right side you can see the voltmeter, which in which the voltage supplied to the whole setup is totally controlled. And near to that is the display of the measurements of volt and amperes and duty cycle of the process. So these are the IoT related components used in this process. So let's start from the encoder. So encoder is fixed to the spindle of the tool using a coupling, and with the encoder the motion of the tool is totally measured. And the TDS sensor, already as I already mentioned, the TDS sensor measures the total diffused solids on the electrolyte. So this TDS sensor gives a digital output directly. And temperature sensor temperature sensor is used to measure the temperature from the electrolyte. This temperature sensor is directly dipped on the electrolyte, and the temperature is of the process of the selection of the electrolyte is directly measured. An ultrasonic sensor and the Arduino board. So in this project, a basic Arduino board, that is a Uno board, is used, as it is very easy to use here. And for the temporary circuit, a breadboard is used here, and a pH indicator. This particular pH indicator used here is a acid pH indicator, which can withstand both acid and also the base. So these are the purchased components till now. Programming language. So when it's come to the algorithm, we have used Arduino programming language for this particular project. So Arduino uses a variant of C++ programming language, that is Arduino is another variant of the C++ programming language. The code is written in C++ with an addition of special methods and functions. That is, in here, C++, Arduino is an another process another language where C++ is written with the extra methods and functions. So Arduino is an open source electronics platform based on easy to use hardware and software. So basically, Arduino is a open source where it is easily available and easy to access. And Arduino boards are able to read inputs, light on a sensor, and turn it into an output. So the basic work of the Uno board, that is an Arduino board, is this material removal mechanism. So based on the material removal mechanism, there are two types of material removal mechanism in this ECDM process. The first one is material removal mainly occurs due to melting and vaporization due to discharge sparking between the cathode and the workpiece caused due to the formation of gaseous layer in the gap. So that is vaporization. So melting material removal. First, the first mode is the electrical mode, where the material removal is happened due to the melting and vaporization of the discharge of the spark. So other mode of material removal is due to the chemical reaction between the electrolyte and the workpiece in this process. So that is the second mode of the material removal mechanism. References. These are the two references. These are the two references which are taken for this project. First one, Smart City Solutions Comparative Analysis of Waste Management Models in IoT enabled environments using multi-agent simulation. So here they have concluded that the ultrasonic sensor is the most efficient sensor. So I take this as a reference in order to use the ultrasonic sensor in this project, as that will be the compatible sensor for this project. Integrating IoT and mechanical systems in mechanical engineering applications. Okay, this this is a review journal, not a research journal. In this, they they'll introduce a term like MEMS, that is micro electronic electromechanical sensor, micro electromechanical sensors. So MEMS, micro electromechanical sensor, will be are the miniature sensors, which are the combination of electrical and also the mechanical components. These sensors are the miniature versions of every sensors and most efficient too. So most the wide range of the span will be embedded using these sensors. So I've taken this as a reference too. Thank you.